The elements necessary for life are scattered across the universe. While there is only known life on Earth, finding life elsewhere in the universe is a key objective of current astronomy and planetary research. We will soon be able to study the composition of atmospheres on planets orbiting other stars, in great part because of next-generation observatories like the James Webb Space Telescope. One or more of these planets may have a chemical signature of life, hopefully. Exoplanets that are habitable. Where there is liquid water, such as beneath the surface of Mars or in the oceans of Jupiter's moon Europa, there may be life. However, it is very challenging to look for life in these locations since they are remote, and because doing so would entail sending a probe to return tangible samples. It's conceivable that life will initially be discovered on planets circling other stars, as many scientists think there's a significant probability that it does. The Milky Way galaxy alone has an estimated 300 million potentially habitable planets, and some habitable Earth-sized planets are barely 30 light-years away from Earth. These planets are effectively the neighbors of humans in the galaxy. By using indirect methods that measure how a planet influences its neighboring star, astronomers have so far discovered more than 5,000 exoplanets, hundreds of which may be habitable. Astronomers can learn a little bit more about an exoplanet's mass and size from these observations, but not much more. Renowned exoplanets. It's challenging to choose just a handful among thousands available. The habitable zone's small, solid planets stand out on their own, but we have highlighted 5 additional exoplanets that have widened our understanding of planetary formation and evolution. As was already mentioned, 51 Pegasi b was the first verified planet to orbit a Sun-like star. It revolves around its Sun at about the same distance from our Sun as Mercury and has half the mass of Jupiter. Due to its proximity to its parent star, 51 Pegasi b is probably tidally locked, which means that one side is constantly facing the star. Even though it was detected using the Doppler wobble method, HD 209458b was the first planet discovered in 1999 to transit its star, and in the years that followed, further discoveries piled up. The temperature profile and the absence of clouds were among the first characteristics of its atmosphere that we could pinpoint for a planet outside of our solar system. 55 Cancri e. Because this super-Earth circles a star that is visible to the naked eye, astronomers may examine it in more detail than virtually any other system. Only 17 hours and 41 minutes make up its year. The planet may have a diamond core and be carbon-rich, according to theory. When it was found in 2001, HE 80606b held the title for being the most peculiar exoplanet ever found. It's likely that the cause of its peculiar orbit, which resembles Halley's Comet's orbit of the Sun, is another star. The planet's ecology would be very unpredictable due to its eccentric orbit. The planet WASP 33b was found in 2011 and features a stratosphere that acts as a type of sunscreen layer by absorbing part of the visible and ultraviolet radiation from its parent star. This planet not only orbits its star backward, but it also causes vibrations that the most satellite can detect. Searching for biomarkers. To look for evidence of life on a distant planet, astronomers study starlight that has interacted with the surface or atmosphere of the planet. The light may have a biosignature, which is a visible signal whether life has changed the surface or atmosphere. Even though it could sustain simple, one-celled life, Earth spent the first half of its existence with an oxygen-free atmosphere. During this early period, Earth's biosignature was quite weak. When a new family of algae emerged 2.4 billion years ago, that dramatically altered. The photosynthetic mechanism utilized by the algae results in free oxygen, which is oxygen that isn't chemically bound to any other element. Since then, a distinct and perceptible biosignature has been transmitted by light traveling through Earth's oxygen-rich atmosphere. Certain wavelengths of light are more likely than others to stay trapped in the surface of a gas or substance when the light bounces off its surface. The reason why things have varied hues is due to the selective trapping of light wavelengths. Because chlorophyll is especially effective at absorbing light with the red and blue wavelengths, leaves appear green. When light strikes a leaf, the longer wavelengths of red and blue are absorbed, leaving predominantly green light to reflect back into your eyes. The pattern of missing light depends on the specific properties of the material with which the light interacts. As a result, by measuring a planet's particular hue of light, astronomers may infer something about the makeup of the atmosphere or surface of an exoplanet. This method may be used to find the presence of certain atmospheric gases related to life, since they leave behind highly clear traces in light, such as oxygen or methane. It may also be used to spot unusual colors on a planet's surface. On Earth, for instance, plants and algae employ pigments like chlorophyll to collect certain wavelengths of light in order to carry out photosynthesis. A sensitive infrared camera can identify the distinctive colors that these pigments emit. This tint may indicate the existence of chlorophyll if it were to reflect off the surface of a far-flung planet. Earth and space telescopes. These minute variations in the light coming from an exoplanet with the potential to support life need a very large telescope to be able to detect them. The James Webb Space Telescope is the only telescope now able to accomplish such a feat. James Webb obtained a spectrum scan of the gas giant exoplanet WASP 96b when it commenced scientific activities in July 2022. The spectrum indicated the existence of water and clouds, although life is unlikely to exist on a planet the size and temperature of WASP 96b. However, this preliminary data demonstrates that James Webb is able to recognize minute chemical signatures in exoplanet light. Webb will point its mirrors toward TRAPPIST-1e in the next months, which is just 39 light-years away from Earth and may be habitable. By observing planets as they transit their host stars and catching the starlight that is refracted by the planet's atmosphere, Webb may search for biosignatures. The telescope can only closely examine a handful of the closest possibly habitable planets, since Webb was not built to look for extraterrestrial life. Additionally, it is limited to detecting changes in atmospheric concentrations of carbon dioxide, methane, and water vapor. While some combinations of these gases may indicate life, Webb is unable to detect the presence of unbonded oxygen, the greatest indicator of life. The brilliant light of a planet's host star will be blocked by advanced ideas for future, even more potent space telescopes to show starlight reflected back from the planet. To better view something in the distance, think of doing something like to blocking the sun with your hand. Small interior masks or big, exterior, umbrella-shaped spacecraft might be used in future space telescopes to accomplish this. After starlight is blocked, studying light reflecting off a planet is much easier. The Giant Magellan Telescope, the 30-meter telescope, and the European Extremely Large Telescope are three more gigantic ground-based telescopes that will be able to look for biosignatures. These telescopes might potentially be used to look for oxygen in the atmospheres of the nearest planets, despite the disadvantage of Earth's atmosphere distorting starlight due to their immense power compared to current telescopes on Earth. Does biology or geology apply? Astrobiologists will only be able to identify significant biosignatures emitted by planets that have undergone a full transformation by life, even with the most powerful telescopes in the next decades. Unfortunately, the majority of gases generated by terrestrial life may also be created by non-biological means. Methane is a gas that is emitted by both cows and volcanoes. In addition to producing oxygen via photosynthesis, sunlight also breaks water molecules into oxygen and hydrogen. When searching for extraterrestrial life, there is a considerable likelihood that astronomers may find some false positives. Astronomers must have a thorough understanding of a planet of interest to determine if its geologic or atmospheric processes may resemble a biosignature in order to help rule out false positives. The next wave of exoplanet research may be able to meet the standard for the remarkable evidence required to establish the reality of life. The James Webb Space Telescope's first data release provides us a preview of the great advancements to come. Thanks for watching. Take a look at some of our other videos. Don't forget to hit the like button and subscribe to our channel. Until next time.